There's not much to do in Antarctica except scientific work. You could check out the wildlife, like some cute penguins and seals. And you'd get to see the occasional whale swimming around. Antarctica is one of the biggest lands out there that's only inhabited by scientists and researchers from all over the world. These scientists dug a hole through some pretty thick ice to study the ancient air and how the atmosphere cleans itself. They used a special drill and dug a clean cylindrical hole 450 feet below the surface. Some of this ice can be up to 800,000 years old and is a good indicator of what the climate was like in the past. It's like checking out tree rings to determine how old a certain tree is, except it's more complicated than that. After the effortless digging, they decided to drop some ice to the bottom of the hole to see what would happen next. They heard some really unusual sounds. It felt like being on a spaceship traveling through a bunch of obstacles with many rocks smashing into each other. The pitches changed over the quick descent of the block of ice, ranging from high pitch and ending with a low heartbeat-like sound. The scientists were puzzled when they first heard this and dropped some more ice, only to find out that the same type of sounds were being produced, just in different variations. They couldn't tell what was down there and, more importantly, why these kinds of sounds were produced. Antarctica boasts quite a few volcanoes, many of which are under super thick sheets of ice. Scientists discovered 91 volcanoes and claimed there could be more, potentially making it the most extensive volcanic region in the world. While they were doing regular scientific research, they came across many unmistakable large cone-shaped figures underground. Some were as deep as 2 miles in the ice. Some of the peaks were over 3,000 feet tall and dozens of miles across. But on the surface, it's as plain as a sheet of paper. They may have dropped that block of ice inside an actual volcano that they were standing on, but it's unlikely. Even though the underground volcano presence was discovered by accident, there's a small chance they were actually standing on one where they had their workstation set up. It's more likely that they worked in an area where studying ancient climates is easier and less dangerous than other places. They collect ice samples and study them in a lab. It's like discovering a prehistoric insect embedded in amber millions of years ago when dinosaurs used to roam the land. But instead of little bugs, scientists study ancient dust, air bubbles, sea salts, volcanic ash, and anything else that may have come from the environment. They can practically tell how the climate was during that time. These ice samples might show that Antarctica's western ice sheet melted when the Earth's climate warmed up. If it did, then it's likely to happen again. That would mean sea levels rising, affecting coastal cities and small remote islands. But scientists aren't sure it's true, despite some evidence to back it up. The process of studying ice samples can take a week or even a year, depending on what they find. They crush or melt the sample bit by bit. And like those tree rings, the deeper the layer, the further we go back in time. In order to study ancient bubbles trapped in ice, researchers have to crush the samples under a vacuum hood to keep the air out while extracting the air and putting it in vials. There are various instruments and devices to study the ice samples, but because it's so sensitive to damage, each measurement must be in a clean room setting so that nothing gets compromised. The scientists have to wear proper bodysuits and many layers of gloves and constantly get ventilated. Even something as tiny and insignificant as a fingerprint can ruin a sample. They look for certain patterns to see changes in the atmosphere's composition and temperature. But dropping a few blocks of ice down a hole wouldn't be so bad. The reason why it made such a peculiar sound is the same reason why a moving car sounds different when it's honking than when it's stationary. The scientific word for it is the Doppler effect. It's an obvious change in the frequency of a wave with respect to an observer who is moving relative to the wave source. The effect doesn't mean the frequency of the sound changes, it just shifts. And this can be said about other types of waves, like water and light. But sound waves are the most popular ones when it comes to the Doppler effect. So, when the scientists dropped the ice block down the bottom of the hole, the sound waves traveled back up and bounced around the narrow tube where they drilled. That's why they got the pew pew sound. Let's not forget that this ice block traveled 450 feet beneath us. Oil ships dig holes in the oceanic crust that go thousands of feet beneath the Earth. The Kola super deep borehole in Russia is the deepest hole ever made by humans. It goes more than 40,000 feet below the surface and took almost 20 years to reach 7.5 miles. Below it is only half the distance to the mantle. In terms of the whole Earth, this very deep hole is literally scratching the surface. This wasn't a hole to dig for oil, and wasn't in the ocean either. The drilling was stopped in 1992 when the engineers found out that the temperatures were 100 degrees Fahrenheit higher than they predicted. And then it was abandoned, and it's just been a barren hole now. But that's the closest we've dug to the center of the planet. The scary thing is that some of the workers on the site could hear voices coming from within. All the way in Yemen, an ancient hole exists in Baroot, in the east of the country in the middle of the desert. It's actually closer to Oman than to the capital Sana'a. This hole has puzzled experts and locals. Unlike the holes in Russia and Antarctica, this wasn't man-made. Or was it? It's been around for many years, and the locals try to steer away from it. They don't even like talking about it, since they claim it brings bad luck to those around it, or to whoever utters its name. They claim it was created as a prison for spirits, but many rule that out. The hole is 98 feet wide and somewhere between 330 to 650 feet deep. You can also hear strange sounds coming from the inside. But according to some scientists, the well has little to no ventilation and barely has any oxygen down there. So it's unlikely that anyone or anything lives down there. The Challenger Deep in the Mariana Trench caught some low-pitched grumble sounds in March of 2016. Some of these grumbles were followed by screeches. They caught these sounds in a span of weeks, using a titanium-encased microphone so that the immense pressure of the lowest point on Earth wouldn't crush it. They had to lower it slowly as well, since it's 1,000 times the atmospheric pressure at sea level. For 23 whole days, the microphone recorded typical sounds of whales passing by and boats sailing across from above, and even rumbles of nearby earthquakes, but they still couldn't determine what caused those initial sounds. The researchers couldn't understand if the noise from the bottom of the Mariana Trench was caused by humans or was natural. They also wanted to know if these sounds affected marine life, like dolphins and whales that rely on echolocation. They still can't figure it out, but scientists estimate that the ocean is about 10 times noisier than it was 50 years ago. With technological developments in shipping, submarines, and underwater construction, the ocean will only get louder with time. Northern lights come with sounds, which nobody talks about. They're usually audible when the auroras are at their most powerful presence. Scientists were always puzzled as to what caused the faint popping and crackling, even though they were very far above us. They used some special microphones and found out that the sounds came just 230 feet above us, which is pretty low. They're caused by electrical charges gaining power in a specific region of the auroras. The electrical charges are disturbed by magnetic storms that fire up the northern lights. As a result, some tiny sparks are released into the atmosphere, causing the faint crackling and popping noise.
Now, did you know that there's an astronomical object in which space and time actually swap places? How does that work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs? The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And theoretically, this is what you would see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, The bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we capture the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, First of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now, it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first? Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So, you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So, if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow has survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burnt white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for 1 billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of 2 galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here.
The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the moon. The Earth has numerous satellites circling around it, but the moon is the only natural one. Our moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the moon, leaving craters as a reminder of this collision. If you're standing on the surface of the moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets. Even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile-wide asteroid and its 1-mile-wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called Lunar Standard Time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands, or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, the temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and, in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun.
Ancient as the world, a huge bottomless hole releases disgusting smells filling the area around. Strange sounds come from the depths of this mysterious pit. People are too afraid to walk nearby and discuss this hole out loud. If you look down there, you'll see nothing but ominous darkness. All this sounds like a plot from some horror movie. But this is reality. This creepy hole really exists, and now we're going there to find out what it is. You get on a plane and fly to Southwest Asia. Then you go to the south of the Arabian Peninsula. You get in the car and drive to the place called the Well of Baroot. Nobody agrees to go with you because they believe this place is so dangerous. It's located in the desert of Yemen's Al-Mara province. To get there, you drive through dunes and lifeless plains. The closer you get to the hole, the quieter it becomes around. There's almost no vegetation, and you don't see any animals. Only a few birds fly by. Your GPS says you're almost there. You stop the car, get out, and an unpleasant smell immediately sneaks into your nose. You can't figure out what it is. Some people think the hole smells like rotten eggs. You cover your nose with a bandage and head forward. You still feel the odor even through the fabric. You take a few steps forward and finally see it. A giant hole in the middle of the desert. It's 100 feet wide. This is almost the size of a basketball court. But it's not the size that scares you, but the darkness. It's so black that you can't see anything. It's like someone spilled a spot of black paint in the middle of golden sand. The sun's shining brightly, but the hole absorbs all the sun's rays. People flew over this place in a helicopter. Photographers used the most powerful lenses for their cameras to see at least something, but they caught nothing but darkness. Even a special drone was floating directly over the pit but couldn't notice anything. And the darkness is so deep that no one has been able to find out the exact depth yet. According to approximate calculations, the depth of the hole is somewhere between 320 and 820 feet. This is almost half as tall as the Empire State Building. You throw a stone into the hole, hear it knocking against the walls. With each knock, the sound becomes quieter. You can't hear the moment when it touches the bottom. You decide to spend the night in the car next to the hole. For several hours, you toss and turn in the seat and can't sleep. Finally, you manage to do that, and you're having a real nightmare. Terrible monsters come out of the hole and surround you. Fortunately, the first sun rays wake you up. Locals also believe this place is a prison for some evil creatures. They scream and emit an unpleasant smell. You hear strange, scary sounds and can't explain their nature. The smell is so disgusting that you get an attack of nausea, so you move away from the hole a few feet to the side. At the moment, the giant hole in Yemen is one of the most poorly studied and mysterious wonders of nature. Scientists still don't know where it came from, what's hidden inside, and how old it is. Many people say the hole is millions of years old. Perhaps it'd been formed before the time when dinosaurs walked on Earth. The worst thing is that it's almost impossible to explore the hole. There's very poor ventilation inside and almost no oxygen. This makes any research dangerous and expensive. Locals are afraid to talk out loud about the hole because it can bring bad luck and troubles to life. Also, some legends say the Well of Baroot threatens all life on the planet and can cause the end of the world. For centuries, there were legends that evil spirits that live down there sometimes get out. However, there are also more scientific hypotheses. Maybe construction works created the hole. It could be soil drilling or mining. All this could have caused vibrations inside the Earth's crust and create the deep well. Experts say that erosion of limestone or moving geological salts or brines could have created this pit. There's also a scientific theory similar to the legend about the end of the world. It says the big hole is the mouth of a dormant supervolcano. At any moment, it can wake up and spew 1 million tons of lava and volcanic ash. Maybe further research will be able to solve the mystery of the hole. Now we're going to another mysterious hole. This time it's located not on the ground, but in the water. After the hot sands of Yemen, you plunge into the cool waters of the coast of Belize. Here, you're going to visit the Great Blue Hole. You're sailing on a boat. The water around is blue, but as soon as you get into the hole's territory, the water becomes darker. The huge black pit lies right in the middle of the blue sea. It's 1,000 feet wide and 400 feet deep. The Statue of Liberty could easily fit inside. The most interesting thing is that the hole has a perfectly round shape. It's like someone created it artificially and used it as a huge storage. For a long time, it was believed the hole was created with outer space technologies or by representatives of an ancient disappeared civilization. Unlike the pit in the middle of the desert, you can go down into this one, and some people did it. The theory about the artificial origin of this hole was rejected in 1971. That year, the famous researcher Jacques Cousteau went down there and proved the Great Blue Hole was created by nature. It happened hundreds of thousands or maybe millions of years ago. Thanks to the structure of the stalactites formations discovered inside, he found out about a strong earthquake that occurred on the planet about 200 million years ago. There was a shift in the tectonic platform. After that, the ground collapsed more and formed a funnel. It happened at the end of the Ice Age when the ice began to melt. But this isn't just a deep pit. There are many underground caves inside. It's like a long maze where you can easily get lost. To dive into this underwater cave, you'll need a large supply of oxygen and a team of professional divers who know these mazes well. So, you put on a scuba suit and 2 oxygen tanks and go down into the water. In the beginning, you meet a lot of marine life, several species of turtles, sharks, octopi, and more than 60 species of corals. And the deeper you go down, the emptier the hole becomes. On the smooth walls, you notice entrances to intricate mazes. Flooded caves are interesting with stalactites and stalagmites. But you don't risk going far into the caves. Just like inside the Egyptian pyramids, some people couldn't find their way back here. So, you decide to go down to the very bottom of the hole. But you can't do this without a very special vessel. So you need to pay a lot of money and rent a submarine. Or you can sit at home and watch the dive into the hole online. At the end of 2018, a team of scientists went on an expedition to the bottom of the blue hole and made a live broadcast. They managed to take new photos inside and created the first 3D map of this place. Closer to the bottom, they discovered new types of stalactites in the form of icicles. These stalactites had been here even before the big blue hole filled with water. Also, a thick layer of hydrogen sulfide was found deep inside. This substance completely absorbs sunlight. That's why you find yourself in absolute darkness. And in this darkness, in the lower part of the pit, scientists found remains of mollusks, turtles, and snails. Sometimes marine creatures got here, but can't get out because of a lack of oxygen. But the most unexpected thing that scientists found there belongs to people. Somehow, a plastic bottle got to the deepest part of the hole.
In January 2022, a volcano eruption happened in the Tonga Islands that forever changed the way we understand GPS signals. This volcano caused a massive disturbance, sending out a colossal mix of gas and debris in the air. It generated a shockwave that traveled across the entire atmosphere, reaching all the way to Alaska, and launched a tsunami over nearby islands. Over northern Australia, it crafted a weird plasma bubble in the upper atmosphere, which disrupted GPS systems for hours. People that happened to be under this bubble and in need of precise GPS waited for ages before their device could receive precious information again. The exact place where these disturbances occurred is called the Ionosphere. It's the place where our atmosphere meets outer space and looks like this buzzing layer where heat from the sun turns gases into electrically charged particles. It can also be seriously unpredictable. changing depending on the weather and thinning out when the sun's rays are less powerful. Because it's electrically charged, the ionosphere helps us with our communication needs. It houses many satellites, including the International Space Station. Here's how changes in the ionosphere can interact with GPS signals. Let's say you're playing detective with your friends and need to find them using a special radar. This radar sends out invisible waves through the ionosphere to locate your buddies. If everything is normal, you'll find their precise location in no time. Should those waves go through a place where the ionosphere particles are a bit messed up, the waves might slow down, get scattered, or change direction, confusing your radar. In the same way, when GPS signals travel through a damaged ionosphere, they can malfunction. Scientists have developed a way to fix this, like special sensors to anticipate changes in the atmosphere. The ionosphere is also sensitive to rockets being launched from Earth, not just storms and volcanoes. At first, astronomers believed these red patches they were noticing in the sky were similar to the northern lights found in Sweden, Finland, or Canada. But they soon figured out there were gaps in the ionosphere. Beautiful to look at, yes, but experts are worried that these crimson areas might be causing communication and astronomy problems that we've yet to discover. Since scientists don't know all the effects of these holes on our environment, it's best to steer clear if you see a red hole in the sky, just to be safe. But at least they seal up within 10 to 20 minutes. Mars has its own eerie set of lights happening in the atmosphere, and you'd think, since it's the red planet, these lights would also be red. Should you ever land on its surface, surprise! At times, the sky turns to a green glow. This unexpected hue could be very important for future Mars trips, since it can help specialists better understand the Martian atmosphere. Or what's left of it. That's because, at some point in its history, Mars switched from being a warm and wet world to the cold, dry plains we know today. How is Mars slowly losing even what's left of its atmosphere? One popular theory is that Mars's weak gravity, combined with the fact that it doesn't have a strong magnetic field, lets the atmosphere escape into space. This vulnerability comes from the solar wind, a constant flow of particles from the sun. The sun's push over millions of years may have thinned out the atmosphere, grabbing the lighter parts. Some scientists suggest another possibility. A colossal impact by another object might have swiped Mars's atmosphere away. Studying this greenish glow is key to understanding what's going on the Martian atmosphere, a place satellites can't directly explore. Since we plan to visit this neighboring planet in the following decades, scientists intend to develop the perfect spacecraft. Knowing its atmospheric density helps us build machines tough enough to handle Martian drag, and we can design parachutes that gracefully descend to the Martian surface. See these amazing purples and greens lighting up the sky? That's not your typical aurora. It's Steve. First discovered by regular people, not scientists, some years back. We now know it's the aurora's more elusive cousin. Steve is short for Strong Thermal Emission Velocity Enhancement and was caught on camera back in 2018 by a bunch of amateur aurora chasers in Canada. They then brought it to the attention of NASA scientists. Here's how this is different from the aurora, starting with the appearance. Steve is more of a magenta streak, while the aurora is usually made out of green ribbons. Auroras happen when particles from the sun interact with the Earth's magnetic field and atmosphere, causing gases to emit light. Steve is thought to be a separate optical phenomenon that sometimes appears alongside auroras. While the exact mechanism behind it is still being studied, scientists believe it is linked with charged particles in the ionosphere that also interact with the Earth's magnetic field. Now that we know where to look, Steve might not be as rare. If you're planning to catch a glimpse of it, you'll need to travel to places where auroras usually happen, like Canada, Alaska, Northern Europe, New Zealand, and Australia. That's because it's never visible on its own. It's powered up when the aurora is extra bright during geomagnetic storms. Auroras can also happen on the sun too. These luxurious lights happen somewhere around 25,000 miles above a sunspot, a dark magnetic patch on the sun's surface. Astronomers have only recently discovered our own sun is capable of generating these lights. So far, they've only spotted aurora-like signals from faraway stars. Here on Earth, the aurora can last anywhere from 15 to 30 minutes, maybe even a couple of hours if you're lucky. On the surface of the sun, though, this phenomenon is a week-long display of intricate lights. Strange lights in the sky can also happen before an earthquake hits. Mexico had its share in 2017, lighting up the internet with pictures of weird celestial shades before a massive magnitude 8.1 earthquake. Some voices in the scientific community wonder if this light phenomenon is indeed connected to earthquakes at all. Others have this theory that such lights are caused by the release of ionized oxygen from the breaking of certain rocks. A photographer from Finland captured these shots of a circular rainbow display in the sky and wondered what might be causing it. It's something pretty ordinary: pollen. These colorful rings are called pollen coronas, and they happen when sunlight hits the pollen in the air at a certain angle. You can easily tell if you're looking at pollen coronas if they're accompanied by star-like sparkles. Those are individual pollen grains, and they come in many sizes. The process is very simple. Sunlight hits the pollen and scatters into different colors. Some colors get blocked or crash into each other, creating a pattern known as diffraction. The pollen in these images is from pine trees, and under a microscope, they look like tiny Mickey Mouses. Those ears are actually air pockets that help them float in the wind. The air sacs all line up in the same direction, creating the elliptical shape of the rings. For these coronas to show up, pollen levels need to be very high. An astronaut up on the International Space Station once snapped this picture of our planet, showing these two weird blue patches of light in our atmosphere. They might seem related to each other, but these lights are two different natural phenomena that just happen to be captured at the same time. The first one down at the bottom is a massive lightning strike that zapped somewhere in the Gulf of Thailand. Lightning is usually pretty hard to spot from way up there because of clouds, but this time it struck between them, firing up the walls around it like a luminous ring. The second blue blob up in the top right happened because of the moon. The way our natural satellite lines up with the space station lets the sunlight it reflects shoot straight through Earth's atmosphere. This turns it into a bright light with a fuzzy halo. It happens because some of the moonlight bounces off tiny particles in our atmosphere, making the moon look blue in this picture. That orange halo curving along Earth's edge is just the atmosphere. Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201. Which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultra-massive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Sears 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. the blazar's luminosity is 300 trillion times that of the Sun, and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter. About 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion! Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is Ton 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a Ton 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. Ton 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment.
A word of warning: when you're in Australia, never stick your finger into these holes. They might be home to burrowing spiders. Some species have a bite powerful enough to pierce nails. It feels similar to a hammer on your finger because of the venom. So always give your boots and outdoor clothes a quick check to be safe. Animals sometimes make homes or look for food in them, especially bandicoots. Silk-lined burrows in shady spots might belong to funnel web spiders. The silk works as a trip line to alert the spider inside about what's happening outside. Look for shiny dark brown to black spiders with finger-like spinnerets at the end of their abdomen. Then you'll find them. Males have a hefty mating spur sticking out of the middle of their second pair of legs. When these spiders feel threatened, they make aggressive moves, rearing up and showing off their startling fangs. These spiders, which belong to the Aranida order, are known for their funnel-shaped webs that widen at the entrance. They patiently wait in the narrow funnel for prey to touch the web, then swiftly capture it. In Australia, large brown spiders frighten people due to their venomous bites. They are infamous for causing people to lose their lives in southern and eastern Australia, particularly in the Sydney area since the 1920s. Quick access to the antidote after a bite is crucial in preventing severe consequences. The next spider is one of the world's most dangerous venomous spiders. Phonutria nigriviter is a spider living in South America. People often call it the Brazilian wandering spider. You see, in Brazil, 4,000 people get bitten by this critter each year. The bites can cause serious issues, such as hypertension, blurred vision, sweating, and vomiting. You wouldn't want to mate with this creature, as you can also face way more severe consequences than blurred vision. In some situations, its kiss can take a life. Apart from messing with humans, this spider has a diverse menu, including crickets, katydids, and even larger options like tree frogs, lizards, and bats. operating under the cover of darkness. These creatures are the most active during the night. They ambush their prey instead of relying on webs. In the daytime, they seek refuge beneath logs or in narrow crevices. They love to be around banana trees, but can be found in urban areas and inside homes too. If you spot them one day, be prepared. This creature's body is covered with thick brown hair and is not that small. In 2013, a London family had to leave their home due to an infestation of Brazilian wandering spiders. The trouble began when an egg sac, hidden in a bunch of bananas, made its way to their local grocery store. No one noticed. When the family bought the bananas, the egg sac broke open. Potentially lethal spiders spread around the house. Over 2,500 people visit poison control centers annually in the U.S. Black widows are spiders with the signature hourglass mark on their bellies. Well, let's talk about their bite. These creatures have a bad reputation because their venom is supposedly 15 times stronger than what rattlesnakes pack. When they bite humans, the bite causes muscle aches and nausea. The venom can even mess with breathing by paralyzing the diaphragm. Despite these cases, most people who get bitten don't end up with serious issues unless they're elderly or very young. These sneaky creatures don't pick just one spot to hang out. You can find them in wood piles, burrows, or among plants that act as scaffolding for their webs. Black widows are especially dangerous for other insects and their mates. After a not-so-romantic mating dance, ladies sometimes go all Hannibal Lecter on their mates. These spiders are architects too, spinning massive webs where females stash a cocoon loaded with hundreds of eggs. Baby spiders move out once they hatch, but the web stays put. Those webs are also traps. Different kinds of prey later join the black widow's spooky snack collection. Yellow sac spiders range in size from approximately 0.12 to 0.6 inches and construct silken tubes under stones, in leaves, or in grass. They're found across the United States and southward toward Mexico and South America. They are venomous to humans and, unfortunately, are commonly spotted indoors. The venom of the yellow sac spider contains cytotoxin. This is a substance that can damage or impair cell function. Reactions like redness and swelling at the bite site are common. Yellow sac spiders are not known for their calm nature either. For instance, a female yellow sac spider may bite when protecting her eggs. These spiders usually come in different light colors. They can be a hassle for people in more than one way. Your car can be in danger too. On rare occasions, they may even set up nests in car engines. Moving on to wolf spiders. They're part of a large and widespread group found worldwide. They're named this way for their wolf-like hunting behavior of chasing and pouncing on prey. Around 125 species exist in North America, and approximately 50 live in Europe. These spiders are typically dark brown, with long, broad, hairy bodies and sturdy elongated legs. Like me. Just kidding. They're super speedy. While they usually create silk-lined tubular nests in the ground, some may conceal the entrance with debris. Others build turret-like structures. A few species also spin webs. Wolf spiders may bite in self-defense. They are venomous, but their bites are not considered dangerous. Some people who are allergic to spider bites may experience nausea, dizziness, and an elevated heart rate. The bite of the spider's large fangs is similar to a bee sting, so it can cause a physical wound at the bite site, and the venom may cause itchiness. The combination of their powerful bite, rapid movements, and startling appearance can be quite unsettling. Beware of the redback spider, a close relative of the notorious black widow. It used to live in Australia, yet it has managed to spread its web across New Zealand, Belgium, and Japan through grape exports. The distinctive red stripes or hourglass marks on their black backs are more noticeable in females. Disturb a female, and you'll see how she can defend her eggs. You're likely to get bitten. These spiders can sneak into shoes or clothing, lurking against the victim's skin while they're dressing. Both male and female redbacks have a venomous bite. Their venom is a cocktail of neurotoxins. It can cause sweating, rapid heartbeat, and swollen lymph nodes. The redback has control over the venom dose, so symptoms vary based on how much is injected. Australia deals with over 250 redback bites annually, many requiring anti-venom treatment. The latest case, when a person lost their life after being bitten, dates back to 1956. Yet it can happen, so stay vigilant and cautious around these stealthy spiders. Let's talk about the heavyweight champion of the spider world, the Theraphosis blondie, casually known as the Goliath bird eater. This giant tarantula can stretch up to 11 inches and tip the scales at 6 ounces. To put it in perspective, this spider is big enough to cover your dinner plate and is certified by the Guinness World Records. The nickname might make you picture a tarantula feasting on a hummingbird, but that's more of an artistic exaggeration dating back to the 18th century. These spiders are more into munching on arthropods and rarely go for bird snacks. Goliath bird eaters don't bother with webs like their spider buddies. Instead, they're all about silk, using it to line their cozy burrows beneath the forest floor. The spider itself looks dangerous, but its bite almost never requires a doctor's visit. It feels more like a wasp sting. Goliath bird eaters are the biggest spidey on Earth. On the other side of the spectrum, we have this guy from Colombia. They are among the tiniest spider species. Grown-up males of this species are 0.015 inches long, tinier than your average pinhead. Females are usually a bit larger. Well, that was creepy, wasn't it?
Did you used to make sandcastles at the beach when you were little? The structure had a moat, so you needed to dig deep. While holding a plastic shovel, you probably thought, how deep can I go? Well, this question motivated a group of scientists in the Far East. They have decided to dig the deepest hole in their home country, China. The drilling team's goal is to reach a depth of nearly 33,000 feet. That's about 1 1/10 times as deep as Mount Everest is tall. The location of the borehole is at the edge of the second largest shifting sand desert in the world, Taklamakan Desert. During a single day, air temperatures there can vary over 100 degrees. The drilling rig is impressive on its own. It weighs some 550 tons and is the height of a 20-story building. And it's pretty powerful, too. It can lift the equivalent of 120 adult elephants. These engineers aren't kidding. One of them compared the project to driving a big truck on 2 thin steel cables. That's why they expect the dig to last well over a year. Their ultimate goal is to drill downward through 10 layers of strata. These are horizontal layers of sedimentary rock. Sounds complicated? Just look at any exposed cliff and you'll notice how it has stripes of different colors. These are the strata I'm talking about. If we translate it from Latin to plain English, we'll get things that spread out. Makes sense. Each layer of rock represents a specific geological period. Remember Spielberg's 1993 blockbuster Jurassic Park? That's just one of these geological periods. It ended some 145 million years ago. But in Central Asia, scientists won't travel that far through time. They hope to reach the rock dating back to the Cretaceous. That's the geological period just after the Jurassic. It lasted until some 66 million years ago. This was the time when T-Rex still roamed North America. But why mount such a complicated operation in the first place? A single goal would be a waste of funds. That's why engineers in Central Asia have several objectives. They want to explore the planet's internal structure. This involves the search for natural resources, such as mineral deposits and oil. Another goal is to collect scientific data on earthquakes and volcanic eruptions. The information will help researchers better predict these events in the future. So, hardcore science is behind this pioneering project, but it's not the first of its kind. Deep in the Arctic Circle lies the Kola Peninsula. And no, it doesn't have anything to do with the famous beverage company from Atlanta. This Kola is a region of great natural beauty, covered in forests and lakes, and an abandoned scientific research station. Inside this crumbling building, a rusty metal cap sticks out from the concrete. It doesn't look that impressive today, but this is the site of the deepest man-made hole on the planet. It is over 40,000 feet deep. That's deeper than the Mariana Trench, 36,201 feet, the deepest place on Earth. Scientists were drilling it for nearly a quarter of a century. The project started in 1970 and finally shut down in 1995. But if you travel to this region close to Norway, you wouldn't be impressed by the shaft. It is only 9 inches in diameter. It would be impossible to fall down such a narrow opening. And despite the figures, the hole is pretty shallow on a bigger scale. You see, the drill bit went through only a third of the Earth's crust. Let me explain. Remember those layers of strata? Yup, that's what our planet looks like on the inside. The three layers are the crust, the mantle, and the core. The crust accounts for only 1% of Earth's mass, and it's some 25 miles thick. But it holds nearly all life in the known universe. The deeper you go, the hotter it gets. At the place where the crust meets the mantle, MOHO, temperatures max out at 752 degrees Fahrenheit. Ouch. There are two types of Earth's outermost shell, oceanic and continental. The crust is thinner under the ocean floor, so why not drill here? Well, the thinnest part is usually the deepest part of the ocean. That doesn't mean that people haven't tried to drill into the seabed. Americans attempted this off the coast of Mexico in 1961, Project Mohole. Drilling underwater was more expensive than anyone anticipated. A few meters of basalt, the researchers were able to bring up costs some $40 million in today's money. Not worth the effort, literally. The Kola super deep borehole also burned money quickly. And that wasn't the only heat scientists had to face. The temperature at the top depth was a staggering 356 degrees Fahrenheit. That was double what the drilling team expected. Their machinery simply couldn't operate in that heat. At this depth, rocks behaved more like plastic than rock. If they had gone deeper, the stones would have the consistency of oversized caramels, but the drilling team gave their best. They even invented a new type of drill where only the tip rotated. There was also a lubricant to smoothen the process. This simply means they pumped a lot of pressured mud into the hole. Yet, they came short. Have scientists completely given up? Not by a long shot. The Japanese built a ship, Chikyu, 20 years ago to drill through the seabed, and they have invested a hefty sum in the project, $1 billion. The mission's goal was to drill into the Earth's crust where it's the thinnest. Under the ocean floor, it is less than 4 miles thick. If the Japanese team of scientists succeeds, it will be the first time humans recovered in situ mantle rocks. What is that? In situ is a Latin term that simply means in the original place. The only time we get to see what Earth's mantle looks like is during a volcanic eruption. A plume of hot mantle rising to the surface will form a volcano. You know the rest. But where are the Japanese researchers planning to drill? After all, they have a huge ship, so it could be anywhere in Earth's oceans. They've narrowed it down to 3 locations: Costa Rica, Hawaii, or Baja. In cartoons, characters often dig up a hole and end up in another country. The idea is that since our blue planet is round, and you dig straight down, you'll end up on the other side of the world. Sounds interesting, but this theory has no grounding in truth, pun intended. Science knows more about outer space than about what's underneath our feet. And digging won't get us far. The temperature at our planet's inner core exceeds 10,000 degrees Fahrenheit. The best heat-resistant materials humankind has developed, tantalum carbide and hafnium carbide, can withstand around 7,000 degrees Fahrenheit. Good enough for building spacecraft, but not good enough for traveling to the center of our planet. But will Jules Verne's famous novel, Journey to the Center of the Earth, ever become a reality? For now, we can only imagine. The vessel that would take someone to the center of the Earth would first have to have great insulation. Then it would have to withstand a pressure 4,000 times stronger than at sea level. Let's talk about the finances. The cost of this imaginary mission would be astronomical. The good news is that you could pay it off with what you find underground. At a certain depth, 93 miles, you'll stumble upon diamonds. They form when all that heat and pressure alter the structure of carbon atoms. The final leg of the journey would take you through the Earth's core. The temperature here is the same as on the surface of the sun. And you'd be traveling through molten iron and nickel. But that's not the weirdest fact. The outer core has low gravity. The mass of our planet would be behind you. So the gravitational force would actually pull your vessel backward. Future travelers to the center of the Earth better have a supercharge button. That would be the only way to reach the planet's inner core. Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years. And it does show. See for yourself. Due to such a long isolation, the conditions inside the Mobile Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave. and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7 feet wide structures mystery circles. The Enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andrés Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andrés Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
Black holes are some of the most enigmatic and sinister phenomenon in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Well, let's have a look-see, okie dokie. So a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans. Petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when the massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our Sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our Sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon that there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it, called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be. Which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll eventually be sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come. Yeah, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled toward the black hole, triggering a massive windstorm. And there'd be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans getting stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions as the planet's crust and mantle were pulled apart. All infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't have even seen that much, because you would have felt the effects of the black hole much, much earlier. Well, back to the future. We'll lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'll also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a glob of putty. And yeah, all this is scary even to imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better than the Earth ever being swept into a black hole. The nearest black hole to our solar system is called Gaia BH1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia BH1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of a threat. Hey, but didn't you say there's a black hole in the center of the Milky Way galaxy? Doesn't that mean it's going to eventually hoover up our entire galaxy, you may ask? Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes. And even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now I think I'll turn my attention to the incredible power of chocolate. Okay, here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard about black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies? Two of them, located 9 billion light-years away from Earth, are expected to collapse into each other. And my oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. Oh, by the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our Sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. Yup. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking about billions and billions of years before a black hole loses its mass entirely. That happens because they're constantly losing their mass every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, but let's just call it Super Far Away Galaxy. You might be asking yourself, well, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently. Long name, but let's just call it Andy. Imagine you're a scientist at Caltech and you're looking at a blazar in your radio telescope and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy. But then, you realize there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer. And the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our Sun. Have you seen our Sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. Now, this is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light. But we really weren't affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies, and they will reach the solar system. But what is this shock wave actually capable of doing? Well, it could stop our Sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, a blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat, we'd all turn into flying particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It's always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including you, me, your cat, and our planet, creates a warp or a distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely different for astronauts on long missions and for people that remain on Earth. And this is why a collision of two mega blazars could mess with our perceptions of space and time, due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that interstellar scene, right? Where the lead character bends the space-time continuum through a black hole? Now, don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazar explosion will happen in approximately 10,000 years. But wait a minute. If this blazar lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born around just 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted from the blazars in the first place, this means that the collapse of the two blazars already took place, and it'll reach Earth 10,000 years from now. This means the shock waves are already making their way through the galaxies at this very moment. But still, it's not something even your great-great-great-great-great-great-great-grandchildren will be around to see.